Hello, this is Mr. Best. Welcome to questions 76 through 81 on Chapter 5. Question 76. Avery and Colin were trying to challenge each other with questions for sequences. Avery was looking at an explicit equation that Colin wrote. T of n equals 4.5n minus 8. A. Write the first four terms of the sequence. So when we're writing the first four terms, remember that term 1, n is equal to 1. Okay, so that's what we're going to plug in. So to find the first term, we plug in 1. We get 4.5 times 1 minus 8. So T of 1 is equal to 4.5 minus 8, which is equal to 3.5, negative 3.5. So the first term is negative 3.5. Now, from there, we could use the fact that it is increasing by 4.5 each time. Or we could say, all right, the second term is, and we could plug in 2. Now this way it's going to take a little bit longer to get through, but if you recognize that it is linear, or it's arithmetic, then we can just continue to add 4.5, and I'll show you that here. So 4.5 times 2 is 9. 9 minus 8 is 1. So the first term is negative 3.5. The next term is positive 1, and that's because we added 4.5. If we add 4.5 again, that's 5.5, and if we add 4.5 again, that is 10. So you can do it either way, but you definitely need to get that first term, and then once you get that first term, because we are having a rate of change of 4.5, it's just being added each time. Part B, what would Avery do to write the 15th term of this sequence? Well, if he's looking for the 15th term, then we would plug 15 in for n, and then you would evaluate 4.5 times 15 minus 8. It doesn't actually ask us to find it. It just said, what would Avery do to write the 15th term of the sequence? So you can do something in terms of describing or saying that he needs to evaluate the equation for n equals 15. And so we could just write that out. Question 77, write both an explicit equation and a recursive equation for the sequence. So we're going to start with explicit, or it doesn't really matter, I guess, but we'll do explicit first. With an explicit equation, we need to know what the change is. So what is that sequence generator? So we're going to be adding 3 each time, so you can see that all the way across. So we're going to be adding 3, but remember, this is term 1, this is term 2, this is term 3. We need to know what term 0 is, so we got to work backwards from that and subtract 3 to get the term 0 at 2. Therefore, we can write the sequence T of n is equal to, it's changing by 3, so 3n, that's the sequence generator again. And then we're going to add where that term 0 would be, which is at 2. So T of n is equal to 3n plus 2. Now we'll do the recursive. And with the recursive, remember, we're now looking for how do we write that next term using the previous term. So with recursive, we're going to say T of n plus 1, which means the next term, all right, we need the previous term. Okay, so the previous term is equal to, or the next term is equal to the previous term, and then what are we doing? We're adding 3 each time. Okay, so this is term 2, ideally, this is term 1, and then you would add 3 to that. Or, if you're looking for term 4, this would be term 4, you need term 3, and then you take term 3 and add 3 to that. So that's what that recursive equation is saying. And then remember, we also need to include that starting value, because otherwise it could be a different sequence. So we need to say something about T of 1, all right, the first term is equal to 5. So T of 1 is equal to 5. So that whole thing has to be part of the recursive equation. Question 78, draw a slope triangle and use it to find the equation of the line shown on the graph. So to write an equation of a line, we need the starting value and we need the slope. So if we do a slope triangle here, All right. How much is the y changing? Well, you're going from 9 to 16, so that's a positive change of 7. And then on the x value, you're going from 2 to 4, that's a positive change of 2. So the slope is the change of y over the change of x, which would be 7/2 or 3.5. Now, we need the starting value. Now, right here, it looks like, it's definitely less than 5, but maybe it's 2, maybe it's 3. Not 100% sure here. So one way that we can do this is we can use our equation now that we know the slope, and then we can choose one of our 2 points that we know for sure and use that to be able to find the starting value accurately. Because right now, if we did this, we're going to be kind of guessing. So 9 is equal to 3.5 times 2 plus b, or 9 is equal to 7 plus b, subtract the 7, and b is equal to 2. So some of you might have said, well, it looks like it is crossing at 2. You would have been correct, but this way we are sure that this works. So we have to write the equation y equals a slope of 3.5 times x plus the y-intercept of 2. 79, find the following product. So this is where we can use our generic rectangle or distributive property. I will show you the distributive property on the first one here. So we're going to take 4x times 4x and 4x times negative 5. So that will be 16x squared minus 20x. And then now we have to distribute the 5 to the 4x and the negative 5. So that'll give me plus 20x and then minus 25. And so we combine our like terms. 16x squared stays there. Negative 20x plus 20x is 0. And then minus 25. Okay, so it doesn't say this. It says find the following products. But what we're saying is 4x plus 5. Remember, this would be your length and your width is equivalent to the area, the sum of its parts, which is 16x squared minus 25. So that's if you wanted to write it as a product and as a sum, which it doesn't ask you to do, but just to kind of go back to things that we had done. On B, you have 4x plus 5 squared. Now, this whole thing is being squared because it's in parentheses. So I'm going to rewrite this just to make sure that we are clear what this means. This is 4x plus 5 times 4x plus 5. So we have another distributive property similar to A, but A was 4x plus 5 and 4x minus 5. So we can use the distributive property again, or you can use your generic rectangle. So when we use the distributive property, we get 4x times 4x, which is 16x, and then 4x times 5 is 20x. 5 times 4 is 20x, and 5 times 5 is 25. So we're getting the same numbers because the values are the same, but the signs can be different. So when we go to combine this one, we get 16x squared, but the 20s don't cancel out. You can combine them, and then the 25 in this case is a positive. So 16x squared plus 40x plus 25 is equivalent to 4x plus 5 squared. So be careful on that one because it doesn't show the binomial times the binomial. You got to expand that out to see that. And just a quick reminder, if you are using the generic rectangle, you would have a 4x, a positive 5, a 4x, and a positive 5. And then you do the same thing. You're going to get 16x squared, 20x, 20x, and 25, and then you combine your like terms. Question 80. Write an equation or system of equations to solve the problem below. Apollo and Zeus are both on diets. Apollo currently weighs 105 kilograms and is gaining 2 kilograms per month. Zeus currently weighs 130 kilograms and is losing 3 kilograms per month. How many months will they weigh the same? So we need to write a let statement. So, what is it that we are talking about? How many months will they weigh the same? So we are talking about the number of months. So we'll let M equal the number of months that they are trying to lose or gain weight, or I guess that are on the number of months on diets. I'll do that. Okay. Apollo currently weighs 105 kilograms and is gaining 2 kilograms per month. So 105 kilograms, but gaining 2 per month. Okay. So that's the total weight. So maybe we could add another variable here and say W is equal to the weight. And then we also have Zeus, who weighs 130 kilograms, but is losing 3 per month, and that's his weight. So we could use the equal value method because we do have two variables and two equations. And since they're both equal to W, we can say that 105 plus 2m is equal to 130 minus 3m. Now, if you didn't include the second variable of W being weight, that's fine. You could have went right to this equation based on just the number of months, because it does say they want to know when the weight will be the same. That would have been fine too if you didn't create the second variable on this one. So we'll solve by combining our like terms, or at least getting them on the same side first. So plus 3m, that's 105 plus 5m is equal to 130. Subtract the 105. 5m is equal to 25, divided by 5. So m is equal to 5. So how many months will they weigh the same? It will be 5 months that they will weigh the same. Another way you could have looked at this is using a table. Since it is only out to 5 months, you probably could have figured it out pretty quickly as well. But it does say in the directions, write an equation or a system of equations. So we wouldn't want to use a table since the directions do say write an equation. So let's go ahead and answer the question. It'll take 5 months for Apollo and Zeus to weigh the same. So there's the statement I wrote. It'll take 5 months for Apollo and Zeus to weigh the same. And our last question, 81, we're back to solving systems of equations. So we just set up a system. Now we just have a generic one that we're going to be solving. You get to pick the method that you want to use. This first one is set up for elimination with the variable x and y being on the same side. This one is more set up for substitution because y is being solved for. So it looks like the second one, we can go ahead and use substitution because we can take the 3x minus 2 and substitute it in for the y value in the first equation. So that would be 6x minus 2 times, we're replacing the y with 3x minus 2 is equal to 10. 6x minus 6x plus 4, because we have to distribute, so it's a negative times a negative 2, so that's a positive 4. And then what we notice is the x's cancel, and we're left with 4 is equal to 10. But 4 is not equal to 10, so what values of x and y would work? We would have none. These would actually be parallel lines. So this system has no solution. On part B, this one is not set up for substitution or elimination. If you look, the top once again is set up for elimination, but the bottom, you don't have a variable solved for, and you don't have x and y on the same side. So you got to pick what you want to do. You could solve for this y value. It wouldn't be too bad. But we also could just add this y to the other side. And then that would get us in the correct form. So I'm going to rewrite the first equation, 3x minus 9y equals 3. And then my second equation is 2x plus y is equal to 16. So this part right here, I rewrote by adding y to both sides, and it creates that equation now. Now all the variables are on the left, the constants on the right. So we could use elimination. But to do that, nothing eliminates right away, so we're going to have to multiply one, if not both, equations. We could do this a couple ways. If we wanted to eliminate the x, we could get a common multiple of 6. If we wanted to eliminate the y, we could get a common multiple of 9, since it's 9 and 1 right there. Either way would be fine. Let's go ahead and eliminate the x. But to do that, I have to multiply the top equation by 2 and the bottom equation by 3, and then one of them needs to be a negative so that I get an opposite of 6x. So let's see what we get. First equation would be 6x. I'm distributing the 2 to each of these terms all the way across 2. Don't forget the constant. And then the negative 3, you do the same thing to the second equation, but that's negative 6x minus 3y is equal to negative 48. Now you can add the x's, they eliminate. The y, it's equal to negative 21y, and 6 minus 48 is negative 42. So when we divide by negative 21, we get y equals 2. And now you can go and plug 2 back into any of the equations that you have so far. I'll go to the second one where it's 2x equals 16 minus y. And so that'll give me 2x equals 16 minus 2. 2x is equal to 16 minus 2 is 14. Divide by 2. X is equal to 7. So our answer, when x is 7, y is 2. And that satisfies both of the equations. So that's how you solve a system of equations, especially on B that it's not set up for you. You have to do something before you use substitution or elimination.